This is Taranis AcreForward, the ag industry's most thought-provoking podcast. Listen to interesting people as we go in-depth into the issues affecting crop advisors, growers, and farm communities, uncovering the truth about the ag business and using technology to prepare for the unforeseeable. Ready to explore the future? Let's dig in.
Hello and welcome to this episode of the AcreForward podcast. If you've been keeping up with the conversation, you already know that the Taranis team is mixing things up in 2024, not just with different guests, but with different hosts throughout the year as well. My name's Laura Handke, and I work with Aggregate, who serves as the marketing support for the Taranis internal marketing team. And today, I'm excited to sit in the host seat and have the opportunity to ask our guest, Nir Naor, the head of AI for Taranis, all of the questions and your questions around AI and how Taranis is using the technology. Nir, thanks for joining us here today.
Hi, Laura. Thanks for having me.
Absolutely. Well, let's go ahead and get started here today by learning more about you, Nir. Tell us how you came to be involved in Taranis and AI specifically.
Okay, so I'll tell a bit about myself. I'm 46 years old. I'm married. I have 3 lovely daughters, and I'm around 20 years in the high-tech industry, specifically around algorithms and what's now called AI. And I think that I got here because basically what I enjoy most is solving riddles. So I like solving problems. This is what I love most. And it was always from the engineering, mathematical side of things. So I also hold of a bachelor degree in math and in industrial engineering and a master's degree in engineering. Basically, I think 5 years ago, I joined Taranis as head of AI. And this is 5 years from then is now.
Very good. Well,
yeah.
Solving riddles, you certainly came to the right industry because that is the essence of agriculture, is solving riddles every day. How are we going to feed more people with fewer acres? And Taranis is certainly poised to make that happen. So, preparing for this podcast and putting questions together, I reached out to some of the chat groups online and asked some questions because I think there's so many questions around AI today and what's happening and how it's being used, especially in agriculture. And so one of the resounding messages that I got back, or the takeaways, was, what is AI? I think that there is so much confusion around the technology and what it is today, and help us with that, Nir.
Okay, so I think I'll take you to a bit of a journey back in history. Just bear with me a bit, because if you've asked yourself what's AI, what's the first thing that you do when you ask yourself a question and you don't know what it is? What do you do at the moment at these times? You probably Google it, right?
Absolutely,
okay.
Yes.
So Googling things, okay, it's Google became a verb, okay, because basically if you take us back in time, I don't know, 40, 50 years ago, the internet was something that didn't exist for the consumers. So once the internet was available and data was more accessible, then people started asking themselves, okay, how can I find things that I'm looking for? So the search engine started, okay? So it's a solution. It's an algorithmic solution to a problem, a data problem for that, in that sense. So, and I'll ask you a bit of a more advanced question. What would you do now if you want to ask such a question? And I'm not sure that everyone in our audience does that, but it's becoming more and more common to go and use ChatGPT-like solutions. So we went from Googling things to, hey, Google, Alexa, Siri, do something for me, to I want to scan vast amounts of information and get the information that I asked for, not something that someone wrote about, just an answer to my question. So basically, the enabler for everything is you can say that this is AI. Okay, basically AI, and what I did just as an interesting thing to share, I went to ChatGPT and I asked, "What's AI?" And the answer is very simple. I'll read it. AI, or artificial intelligence, refers to the simulation of human intelligence processes, human intelligence processes by machines, and specifically computer systems. So basically, this is my answer as well, because AI is a concept. Okay, is a concept. We have the human intelligence, and AI basically means let's try and do something similar to this wonderful machine called the human brain, and let's do something similar with computers. So AI is a concept, and it basically relates to applying machines to solve complex problems, to deal with the huge variability of real-world data, and basically be able to learn. Okay, and I use this term because it's important. I think that one of the things that differentiates AI, okay, or machine learning in its let's say basic terms, is a learning process, and we'll probably discuss it a bit later. But as part of the AI process, we teach the machine, okay, which is, if you think about it, sounds like a bit strange or absurd, but this is how it's called, because we are training it, we are teaching the machine to solve problems that are complex, that are not something that we can write a simple algorithm to solve. Okay, a simple algorithm meaning designed by human per se. Okay, so this is
I know
general.
in past conversations, and I'm sorry, I didn't mean to interrupt. There's a little bit of a delay here. I know in past conversations that we've had, everything seems to get lumped into this ag tech umbrella. And you've made clear AI is different from ag tech. Explain a little bit about how the differentiators work in your mind, Nir.
Okay, so I'll say this. When you talk about ag tech, you basically refer to technological solutions that are given to problems from the agriculture world. So the ag tech basically refers to any problem that probably our audience knows better than I do, which are related to every aspect of being a farmer. Okay, so it can be financial, it can be related to manpower management, it can also relate to decision making, etc. So every aspect of the agriculture, let's say, life cycle is a relevant problem in ag. And the tech part basically means taking technological solutions and applying them to solve these issues. So it can relate to anything from software to robotics to AI to data management to whatever. So so ag tech probably is, let's say, the thing that groups all those types of solutions together. And AI is basically one approach that allows you to do something different with the data. And I specifically, if I go back to my previous answer about the ChatGPT, like, okay, relatively new engines, you can say that the technology brought us the ability to collect vast amounts of data. Okay, data is everywhere. And our data, not only the world data, our data is huge. And basically, I think that one of the things that AI allows us to do is to better understand what can we see in the data, what can we understand from the data, what insights can we make out of it, and maybe there are even hidden patterns in it that it's hard for a human to understand, but a machine can grasp it, because it also is built on statistical base that can be leveraged on large amounts of data. So so I think that if I look at that, and AI is another technology that can be applied, and I think that AI is maybe we got the understanding from the previous question, from your previous question, then basically AI can go with any one of the technologies that you add, because it only adds another layer that says, okay, I'm not only solving something very simple, I'm also able to take the larger amounts of data that we collect, the more complex decisions that can be made in the specific solution we want to create, and allow the consumer to get a better experience when interacting with the systems. So there are different ways to use AI, but it's a technology like every other technology, and it can be added in any aspect of any solution almost.
Mm-hmm. And so the differentiator there is really its ability to learn and the training that goes into it on the front end, correct?
Correct, yeah.
So you referenced ChatGPT now a couple of times, just seeing the evolution that system has made, gosh, just in the last year. When we think about how far AI has come, and you've been involved in this space for, going on 2 decades now, tell us about the evolution and how far you've seen it come in that time.
Okay, perfect. So I think that, and I started with this with an internet example. I think I heard a comedian saying that we are the last generation that knew what's the world without an internet. So it's very,
so
very funny, but it's so true. And to think about it, then if you take about 20 years back, then you didn't have also the smartphones that are now everywhere. And now we are in the midst of the AI revolution. And I also read that in some articles it is referred to as the fourth industrial engineering revolution. Mm-hmm. Industrial revolution, sorry. And this is a real thing, and I think that experiencing that everywhere, I think that we all experience that, and this is the beauty of it. So I experience it internally because I'm in the industry, and I see the changes, and they are fast, and they are and this industry is very dynamic, and it changes all the time. This is part of what makes this very exciting for me. But I think that you see it and you feel it as a consumer as well. And as you said, ChatGPT is already becoming, or ChatGPT-like. There are other solutions that are doing similar things now, and it's becoming the way we interact with the data, the way we interact with the world. And I think that this is amazing. And if you go and look back at the history of this area of the AI, okay, for instance, then basically I think it was around 1950 or so, then neural networks as an idea became more realistic. And neural networks is basically, I think, the stepping stone in AI for the last couple of years, and everything is added on top of it. But the neural networks is not a new idea, okay? It existed even before that. It's just that on the 1950 is sort of, I think this was the time, the method for using that, the methodology for using that, the algorithmic way of using that, for harnessing the data and into a solution that works was materialized. But that didn't suffice as well, because basically in the later, I think it was only in the later years of the last decade, basically the hardware was strong enough to do those calculations in a way that will produce a relevant solution to use. So basically we're talking about the last 20 years or so that this became something that is dramatically changing our lives, and it is dramatically changing our lives. Yeah, definitely.
Every day. And it seems like the change has become more rapid. So, you mentioned smartphones, and, if we think back to the first smartphones that hit the market and how far we've come in such a short amount of time, and it seems like AI is moving infinitely faster in the progression. And that's because of the learning, correct? It just continues to take in information and learn more and more, and a little scary, don't you think?
Yeah, I think that this is where the discussion becomes philosophical, I think. But it depends on, you know, how you perceive this revolution as threatening or as an enabler to do more powerful, to give more powerful solutions and to go further with technology. So I think that it's better to look at it on the other way, to look at it on the other side of this coin, and be aware of you know, the risks and understand them. But I don't think that, you know, we need to be afraid of AI. I think that this is relevant for every revolutionary change in history. It's frightening because it's a change, but I think that's it.
Well, and
Yeah.
I love that you made that point, that we don't need to be afraid of it. We need to embrace it. Certainly in agriculture, when we think about the amount of change that we have witnessed just in the past decade in agriculture, in the agriculture industry, and how quickly AI has the potential to move our industry forward. How much data is too much data? Well, it depends on how much you can process. And with AI, that number seems almost infinite, or that amount seems almost infinite. And so, you know, when we start talking about the opportunities that AI delivers to agriculture, really, we're just on the horizon of that. We have a long way to go, and it seems like things are getting better every year. And so, Nir, talk a little bit about how Taranis is harnessing AI and how you're using that technology to push the industry forward. I know you guys have a massive library of data that you pull from, so
Yeah.
let's start there.
Okay, so I think that I'll throw in some numbers just to get the idea of you know, I've been 5 years in Taranis, but Taranis is I think celebrating, I don't know, 10 years or so for its existence in the next year or so. So but in the last 5 years, the Taranis industry, the business changed a lot. So just to throw in some numbers, then 5 years ago, we would have digested, I don't know, a couple of 10,000 of images. And now we are, I think, 100-fold for that. So we are digesting about a couple of millions of images. And this is only because we can harness the capabilities of AI to assist with solving those problems. Because basically what Taranis does, we capture images. I don't know if I'm sure that our listeners know what Taranis does, but just in a glance, then basically when we take the images from drones, the images of fields, then basically we need to analyze them. We want to analyze them, and we want to give the information of what's in the field. Okay, how many plants emerged, where are weeds in the field, what types of diseases are there in the field, and basically we want to do it fast, because we want to impact on the decisions that needs to be made that day or the day after. So being fast is an important characteristics of the solution that we need to give, and being accurate is also another characteristic. So we must have good solutions to solve this, and we did, because basically when I joined 5 years ago, we were a small team. We're still relatively a small team for AI team, but we had zero automation 5 years ago, and now we are almost 100% automated using AI. So that's a huge leap for Taranis, because basically that's the only enabler to achieve scale and consistency in the analysis that we supply to our customers. So I think that that's a dramatic change, and this is definitely because we have a hold of I think the largest library of images and annotations, data points aerial imagery that can be used for training the AI machines. So I think that last time I checked, it was around 20 million, I think, images, and I think around 200 million data points, which is huge.
And growing every day.
And
growing with every flight.
Yeah.
So you mentioned digesting, how AI is digesting the information. So take us back and walk us through the process of how those images are collected, how they're fed into the AI, and then how the AI learns from them so that it can continue to grow and produce more information.
Sure. So I'll start with the first part of your question, because I think that this is I think the more business related process. But basically our Taranis operation, which is, I think, amazing, really in the complexity of the operation in Taranis is huge. But we need to basically get to the fields on time, and the window that we have to get there is very small. But we have huge amount of pilots that are working with us, and they are dispatched on a timely manner to reach the fields and scan them. We have ways to build the flight plans according to the fields. We collect the data, collect the images. We make sure that they are in good quality, and then basically we upload them and process them using the AI models. So the AI models as well have different, we have different models to solve different problems, and everything in the system is routed so we can get the right analysis done on the relevant images. And basically this is, I think, the main part of the AI work in Taranis so far. So it's taking those images, which are unstructured data. It's just a bunch of pixels, and transforming them to structured data. So basically we can tell this image has this weed over here, this weed over there. There are such and such plants, and this is where they are. And here we see a disease, here we see an unhealthy crop, here we see an insect. So that's something that you can collect in a database, and you can search and query basically. So this is the main AI engine. But after that, basically what we do is digest it one step forward, because basically what interests our customers is not the raw data. It's basically the agronomical data. So we have another layer that is also built with AI, and of course the software engineers that we have in Taranis, and basically we create the, let's say, agronomical insights from the data that we collected. And we have the different applications like the Taranis Connect and Web App that allows us to get the relevant data on time to the customers. So this is, I think, basically the whole flow. And I left one thing out that is, I think, a crucial part of this process, and that's the quality assurance part. So processing with machines allows you to scale. Okay, so you can do things faster. You can do it in large scale, in a relatively reasonable price, let's say. But eventually you need to also make sure that everything that we get out, or let's say most of the things that we get out, are with high quality as we expect them, because the real world is not necessarily similar to the training, to the laboratory part of the work. And I'll go back to the training and evaluation part in a bit, because it's more technical. But we have right after all the processing phases, just before we send out the final results to our customers, we have a team of agronomists that sit down. They have their tools, they have methodological ways to scan those insights, prioritize them according to the, let's say, the ones that are most likely to maybe suffer from issues in the quality. And if necessary, they fix them. Okay, so they send them to humans that fix the annotations, and we fix because basically quality is I think the most important part of what we deliver. So I think that this is the whole process. And if I go back to your second part of the question, so how do we in AI train machines? So basically this is let's say I'll wave my hands a bit, because basically it's more technical, but I think it's the best way I think that I have to explain the training is like you teach an infant to I don't know, distinguish, and I'll go to the let's say the I think most basic example in computer vision, to distinguish dogs from cats. Okay, so you start off by saying here's a dog, here's a cat, here's a dog, here's a cat, and then they start understanding what are the different features that discriminate dogs from cats. What's common between dogs, what's common between cats, and what differentiates the two. So this is a training, basically. Okay, training is, let's say, it's one flavor of training in AI. But this is, I think, the most common one, definitely the one when we use a lot of data to train. But I think that, you know, it sounds simple. Okay, so just feed the machine with a lot of data and tell it, now this is a pig, this is not. Okay, so what's the problem? So basically the problem, or the main challenge for the AI engineers, I think I can roughly divide them into two different challenges. One challenge is fitting the AI mechanisms, the AI architecture, the AI solutions, okay, the available solutions, available set of tools to the problem that is before us. So this is one part of our job. The second part of our job is, once we go through the training, we need to make sure that we balance the data correctly in a way that will expose the machine while training to the variety that it is most likely to meet in real life. Because eventually, when we talked about all the process that we talked just before, basically those are unseen images, because we saw them for the first time. The model handles them for the first time, and that's a totally different process than a training. Okay, there is no answer. You don't know if it's correct or not. So this is our job, basically, to find the right technology, the right architecture, the right solution, and to make sure that the training, when we do the training, that it's relevant to for the test. Okay, so for the tests that come later. So basically, when we train, we use large amounts of data. And the large amount of data basically refers to, or mostly refers to, the variety that we need to expose the machine to, in order for it to understand what's the signal that is relevant to make a decision and what's the noise that it needs to ignore. So those are, I think, when I, again, just wave my hands a bit and try to explain what are we doing when we are training a machine. So this is basically, I think, what we're doing. And just so we understand the training, and I said, I think maybe I mentioned evaluation before. So part of the training, part of the research work that we do, after we have a model, then we evaluate it. We try to expose it to some new data and see how it handles it, and make sure that we understand that the quality we get to is good enough for the product, is what's expected from us to give to our customers. And basically, we assuming that we make sure of that, and we take that and apply that to the inference or the production pipeline. So and a side note, I think that this is, maybe it was understood from what I said, but machines make mistakes. Okay, this is part of the real world. Okay, but we tend to think that humans don't make mistakes, but I can tell you that humans do make mistakes. Okay, so this is also something that I think is a challenge for any organization that uses AI, because if you go to ChatGPT and ask, okay, so what's AI, and it gives you something that you don't want to use, then so you'll ask the question a bit differently. When you're working in the business industry and you want to give value to a customer, that is not, say, used to work with AI, definitely without the, in most cases, we don't have the interface to work with AI in that sense. So not everything is correct, but we are, you know, I think the advantage of using AI everywhere, and specifically here in Taranis, is that we learn all the time. Like humans, the machines also learn all the time, because we expose them to new data, we fix our mistakes, we show more variability in the data, and eventually we only get better in time.
Well, and I think that's such an interesting point that you make, Nir, that obviously humans aren't always correct. Obviously, machine learning isn't always correct. But what Taranis does in the conversations that I've had, and I've had the opportunity to work with the team for a couple of years now, those 6 flights, it's still, even if it isn't correct, it's still allowing you to be proactive and catch those inconsistencies so much sooner than you would have with the naked eye. And then you can come back on your end and figure out where the inconsistencies occurred and go forward from there.
Definitely. And as I said, we first of all, I think that, again, depends on the quality level that we reach, and we raise the bar every year. Okay, we are getting better every year, and as I said, and as I mentioned, we have the quality assurance as part of the flow that we have. As part of the processing flow in production. So basically, it's like every other industry. Okay, there are mistakes, but you learn from them, you fix them, and I think that eventually, like you said, the power of the mass sampling basically is the one that allows you to go beyond the level of quality that you need. Okay, because the ability to go through such a huge amount of images, okay, just for the scouting, for instance, you instead of scouting 5 points in the field, you get, I don't know, 100 samples of the field in different locations. So you don't only get the plant population or the average plant population in the field, you also get the variability inside the field. So that's something you didn't have before. And so,
well, right. And, you know, in visiting with one of the farmer growers that we talked with, just a few months ago, one of the things that he said that was really a light bulb for me was it's an apples to apples conversation. So it may not be right, but you all have the same information and you're all equipped with the same tools to make the same decision at the same time. And I don't think that there's any other platform in agriculture that allows an advisory group to do that. That is such a powerful tool to put in the hands of someone, you know, whether it's a good attribute of what's happening from, you know, performance from products or plant health performance. It's the same information across the board. And so everyone is positioned to look at the same exact information at the same exact time and make that decision going forward. And that has not occurred in agriculture to this point. And so what your team is doing is really revolutionary in terms of, you know, being able to make those conversations happen weeks, certainly days, before they would have otherwise.
Definitely. Yeah, definitely.
So just a really cool technology that I'm certainly excited about. So, you know, as we talk about this a little further, we've established the scalable scouting. That's really the value proposition that Taranis delivers. talk about, and we've already touched on this a little bit, Nir, but talk a little bit more about how this library of images was developed. You guys have the largest library of insights in the world, and that continues to grow each day with every flight. Talk a little bit more about that and how you guys were on the front end of that and developing that years before anyone else in the industry really was.
So I think basically this goes back to the founders that basically I think came up with this idea and engraved on Taranis's flag the AI part, because and I think that when I want to say analyze from a 5 years perspective what made AI so successful here in Taranis, then I think that I'll mention two things. One of them, and I think the most important one, is the company strategy. Okay, so I think that I would say that if someone asked me what would it take for AI to solve the agronomical problems like you did, then I'll say it's not only AI, it takes a village to do that, because basically you need to adjust everything. You need to adjust the processing, you need to adjust the way you collect the data, you need to adjust the way you engineer the data, okay, because basically you need to go through different processes, but you also need to engineer the product itself, because basically there are things that you can say with high certainty that weren't available before, but it's a question of how you relay those answers or those insights to the customer in a way that is, most valuable for him or for her. So I think that there are a lot of challenges here, and it's all over the company. It's not only AI, and I think that this is something that we as a company matured from, having AI to being an AI company. Okay, that AI is one of the core solutions that we give made the difference. And if I said two things that come into mind. The second thing is basically, I think, the strategy of the AI itself, because we adjusted all the time, and I think that this is we talked about it previously, and I mentioned that my motto is let the machine do what it does best and let the humans do what they do best. Don't try to mix the two. It won't work. But and I think that this definitely relates to the way we operate, the way we build the Taranis processing pipeline, including the agronomists that stand on the end and review and prioritize the problems and fix if necessary. And we work with them on a general basis also for the training part. They help us understand and make sure that the data that we use for the training is accurate. And so it's everything. And the strategy for the AI is understanding what's the business most necessary needs. Okay, what is the most important thing that we need to achieve every year? And it changes, because when we started as a small company, it changes and to where we are now. And when we have specific skills or don't have specific skills in this pipeline, then we need to adjust. And I think I use the analogy of turning a switch. Putting AI in a production pipeline is not turning a switch on. You move something from, I don't know, manual position to automatic position. It needs to be, it needs to be adjustable. It needs to be done in a careful way so that the system responds to it in a constructive manner. And I think that this is something that we did here. Again, all the teams here together, the engineering, the agronomists, the product, our customer success, our salesmen, so everyone here aligned to that and adjusted to that and changed every year to make this change from fully manual, I don't know, 5 years ago to almost fully automatic.
Yeah. Well, Thank you for making that clarification that the machine needs to do what the machine does best and the humans need to do what the humans do best. And I think that you have found such a sweet spot in agriculture in meshing those two together. I know a lot of folks in agriculture are worried about, people losing jobs because of AI or because of other technologies coming down the pipeline. And really, at the end of the day, it takes those boots on the ground, having those face-to-face conversations and building those relationships with
Definitely.
retailers, with farmers, because that's really the essence of agriculture is a relationship. And you're such an integral part of that behind the scenes. And so really great conversation here this morning, Nir. Thank you so much. As we look at wrapping up, is there anything that we haven't talked about or covered that you would like to make sure our listeners take away?
I think I will go back to one of the first things that I said, and it's don't be intimidated by AI. AI is a helping tool to access the data, to access the solutions in a more, let's say, human-friendly way. So AI is there, and it's there to help us humans. So that's it, I think.
Well, that is an important note to end on, I believe. And well, as we mentioned here at the beginning, we will have another edition in this series where we'll talk more about the questions that farmers in the United States have regarding AI and how it can help them move their acre forward. Nir, thank you so much for joining us here today.
Thanks for having me, Laura. It was a pleasure.